Hi class, for this example we're going to take a look at example 3 from the central limit theorem, and here's the basic idea. So they're telling us that the data is approximately normal with these two values. So in this case the mean is equal to 92 and the standard deviation is equal to the values of 10. Now it's not asking for a sketch, but I just wanted to provide a sketch, so we're taking a look at what this distribution looks like. So this is going to be technically the values of 92, and the spacing of it is going to be of 10. Actually, this is the value of the mean, which represents the highest value there. Now, the first portion of the problem is just the evaluation of probability, and they're looking that a subject has less than 82 words per minute, and obviously in terms of the subject they're looking at speed reading speeds actually from second grade students. And the first part that we need to do is make sure you declare the variable. At a minimum, we should say that it's a random variable. In this case, it actually has a unit, and the unit is going to be words per minute. Now, the problem is saying less than. So that's the actual statement of less than. And as you evaluate the probability, it's going to be less than or equal. Let me just show you how to run the code that evaluates the probability. So in this case, you're going to be doing a normal CDF. And on the normal CDF, because it's asking for less than or equal to 82, so not to scale, but this is going to be 82. So I'm just going to put that that's 82. And then what we're evaluating is a less than statement. So if this is 82 not to scale, the probability that we're plugging in or evaluating is all the way to the negative infinity within the normal distribution. So as you do the code, and then once again, let me clear this up. To run the code or access the code, you do second in distribution. And then as you actually run it, make sure that you're doing the normal CDF. And then you do need this value here, which is technically the negative infinity, which in this case, we would just put in a negative large value. And then this one's going to go all the way to 82, comma, and then the last two portions are going to be the mean of the distribution, which is 92, comma, the values of 10. And that's the probability. In this case, I'm just going to write it out as this is approximately, and I already have the code here, as you can see it. So this is approximately 0.1586, and then there's a 5 afterwards. I'm just going to round it to, let me do 3 decimal places. So this will be 0.159. And if you're working these on the homework or any other assignment, they may want anywhere between 2 to 4. Some problems they may want more decimal places. So that's actually part A. We're evaluating the probability for one subject. And then the main idea as we do further evaluations is here. When we have a single subject, you're just evaluating technically the standard deviation of the population as sigma or S. And when we have more than a single subject, this value of sigma gets replaced by dividing by the square root of n. And that's the only adjustment that needs to be done. So for example, on this one, the actual C score would have been x minus x bar. Wait, it's a population, so x minus the values of mu divided by sigma over the square root of n. So when you're typing in the standard deviation, which is 10, that has to be adjusted, and you can see how I adjusted it here. 10 divided by the square root of 7, which is what actually evaluates it. And let me just run it so that you see it. In this case, I'm just going to do a normal CDF, and then it's going to start at 94, larger. Now, the larger is just a very large value because we're still looking at 92, which is the mean. So that's going to be the mean. I'm putting the arrows on the graph with a sigma of the values of 10. And what they're asking us to evaluate is greater than 94. So just a little bit to the right of the 92, not to scale. And greater means all the way to the positive infinity. So the part that I'm shading here. And then in the calculator, to emphasize positive infinity, you would just put a very large value. Next, it's going to be the mean of the population, which is 92. And then comma, the last portion is we need to adjust for the 7 subjects, which in this case, we're just going to have another comma, then 10 divided by the square root of 7. And that's actually the code. In this case, about 30% chance that 7 subjects will be reading more than 94 words per minute. So let me write it out. We're talking about, for this one, 0.29, 8, and then I'm just going to carry 4 on this one. Some of the problems are just going to want 2 decimal places, just in case I'm going a little bit further. So please take a look at what the software is asking. And let's move on to the next portion. Now, in the next portion, which is problem C, they want the C-score for part A. And part A is for a single subject. So for a single subject, you're just looking at this formula for the C-score. So for this one, we're just going to be evaluating the following. Your X represents the value that we were plugging in this case 82. So that will be 82. The values of mu were 92 and sigma is equal to 10. These are the values from the population, and let me double check, it's 82. So as you plug it in, you're going to have 82 minus 92 divided by 10, and this is going to give us a -1, right? Let me plug it in and verify. So 82 minus 92, that's going to give us -10 over 10, or -1. In this case, C is equal to a -1. Okay, let's go for part D. And part D, they want the C-score, but for part B. So in this case, X is going to be 94. So X is equal to 94. The mean is equal to 92. And then N is equal to, well, they're using 7 subjects. So in this case, 7 subjects with the standard deviation of 10. So as we plug it in, this one will be 94 minus 92 over the values of 10 over the square root of 7. And then in your calculator, you do have to be careful. You may have to put parentheses, top and bottom. Okay, so please plug it in. I'm getting the following. So I'm getting 0.5292 round to 2 decimal places. So C, it's approximately 0.5292 rounded to 4. Most likely because of the C-score, they're just going to want 2 on the software. So I'm just going to put 0.53. On paper, any of those 2 is fine. Okay, so let me just run on the calculator for you guys, the last one. And then here are ones less than 98, but for 20 subjects. So the code, you're going to actually be doing normal CDF. Less than, since the statement is a less than, we're going to be plugging in a negative value. The upper bound is going to be 98, and then the mean is going to be 92. The standard deviation, we still have 10, but the part that's going to change here is the subjects. So because of the 20 subjects, we're going to put in the square root of 20. And in this case, we're looking at 0.99. I'm just going to keep it to 3 decimal places. So for this one, we're just going to be looking at approximately 0.996. And then you just have the code here so that you see what exactly I typed in for each of those values. That's actually it for this problem. Let me just go back to the beginning, and then the problem's not asking for the sketches. I provided the sketches just to justify what we're punching in into the calculator. So for example, the lower bound, it's technically negative infinity. The upper bound, it's technically positive infinity. So for these values, we just put a numerical value that's really large on the lower or upper end. And then the last 3 questions, they just want the z-scores along with another probability problem. Also, only once you need to actually declare the variable. And as long as the story hasn't changed, in this case, we're still talking about reading, you don't have to declare it. That's actually it for this problem.